In this video, we are going to build a machine learning model to predict the price based on yesterday's price. How does it work in our MVVM architecture? When the user opens BitcoinPredictionView, it asks BitcoinPredictionViewModel for predicted price. ViewModel uses BitcoinPredictionService. BitcoinPredictionService loads Bitcoin price predictor, which will be our model, and this model we will train on historical Bitcoin data from CoinGecko API. So we will create two files, get data and train model in the Jupyter notebook, and we will convert it to our machine learning model, making it our Bitcoin price predictor. This model will predict next day's price, and then we will display the result together with the historical prices. So let's get started with collecting Bitcoin historical prices from CoinGecko. For this, we will need to open our terminal and start our Jupyter notebook. Install Jupyter notebook on your computer if you haven't done it yet. It runs successfully. Now we have to navigate from our browser to the machine learning models. It's a folder in our app. I saved my app in the desktop. So here you see the folder Bitcoin app, and now I have to navigate to the machine learning models. This is my folder, and you should have the same if you followed my previous videos. Here we're gonna create a new file, and let's call it get data. First, what we need to do is to import the libraries. We need requests and pandas. If you haven't installed these two libraries, you might have an error, so please install these libraries from your terminal if you haven't done it before. Now we want to fetch 30 days of Bitcoin market data from CoinGecko. We need the URL, which is, I just copy-pasted. I will copy-paste this in the description, but also you can find this in my Patreon page, which I will always also provide in the description section. So now we need to define the parameters. And our parameters are VS currency. Our currency will be USD dollars, days. We need 30 days, but of course you can make more days or less days. Just for the purposes of this tutorial, we need 30 days. And the interval. We want to do it daily. Let's run it so we don't have any errors. Now, we have to define the variable response and data. Our response is request, get, because we are getting the data from the website. And here we need URL and params equals params. We have here params because we defined it here the variable params. That's why it should match. Now let's define the data. We will have this data in JSON, so we need to type response.json. All right, and let's print it to see what we will get. So you get something like a pair. First number indicates the timestamp. It's in milliseconds. And the second number indicates the price. We need to convert this millisecond timestamp into readable date. And to convert this into a readable date, we use pandas function to date time. Let's type first prices. We will get the prices from our JSON data, and here we also have to type prices because it says here prices. So we want to match them. Now we define the data frame. It comes from pandas. So we do pandas data frame, open parentheses, and we need prices, and we need to define the columns. Columns equal to timestamp and price. Now we need to convert the timestamp. So we copy paste timestamp again, data frame timestamp equals to pandas to date time, open parentheses, data frame, timestamp, and let's indicate the units, which is milliseconds. And we also want to set indexes. Let's run. We don't have any errors. Let's continue. We want to get this data from JSON. We convert the data to timestamp to date time, and we want to save all this data for 30 days in one CSV file. So we say data frame to CSV. Let's call this CSV Bitcoin prices.csv. Let's see the last 5 rows of our data. For this, we have the function tail. Okay, so what does it mean? It means that this price was recorded on the 1st of October 2025. Now we need to train the model. So let's go back to our folder and create a new Python file. We will call this file train model. The same as before, first what we have to do is to import the libraries that we're going to use. We need pandas and we need linear regression. And now we need core ML tools. We will convert our linear regression model into core ML so that it's readable in our app. If you have errors because you have not installed these packages, then open the terminal and run the command pip install requests, pandas, scikit-learn, and core ML tools. Now, let's load the CSV file that we just created in the previous file. So we define the data frame and we use the pandas function read CSV. And if you remember, our CSV is called Bitcoin prices, I think. Now we need the same these 2 lines, so we just copy paste them. And let's create a new column called previous price. So we will shift the column for previous day's price. Now we need the new name, so the new name for the new column will be previous price equals to data frame price, and we get a new column previous price, and we shift by 1 row. All right, and now we want to drop the rows that are empty, so we use drop NA and in place equals true. Let's run. If you're familiar with linear regression, so you might know that in order to run it, first we need to prepare features and labels. So our features are X and labels are Y. Our features will be the previous price column because we train our model based on the previous price. So df, and I will copy paste it. We need values, reshape. Values means that we convert the column from a panda series into a numpy array, which is the standard format for machine learning libraries. And this here, reshape -1 changes it into a 2D array with 1 column and as many rows as necessary. -1 tells NumPy to automatically calculate the number of rows. This is actually a crucial step because machine learning models expect the input X to be a 2D array, like a spreadsheet with rows and columns. And Y is our target, so here we need to define the price because we are predicting the price. And let's also write values. Why do we need values here is because this converts the column into a 1D NumPy array. And our target is expected to be a 1D array, so we don't have to reshape it here. And now finally, let's create a model. We are fitting the model, which means that the model learns the relationship between X features and the target variable, which is Y. So let's train the model. We need to convert our model to core ML. So we define the variable ML model. And now we use the functions from scikit-learn. So we do CT, converters, scikit-learn, and convert. Now we pass the model input features, output feature names, and we close the parentheses. So let's convert it. And the last step we have to do is to save everything to ML model file. So we write ML model, save, and we will call it Bitcoin price predictor. So let's try to save it. Now let's check that we successfully saved our model. And we will go to machine learning models, and as you see, we have here get data file, train model file, and the machine learning model converted. Now that we have our model, let's create the prediction service. We go to the services folder and we create new empty file called BitcoinPredictionService. First, we will import core ML. Here we will load our pre-trained AI model and use it to make predictions. Let's start with creating the class. And we will need here our private variable model. This will be our ML model, which we called it Bitcoin price predictor. Now we need the init method. It will run once when the service is first created. So we type do let config equals to ML model configuration, and our model equals to try Bitcoin price predictor with the configuration config. Alright, and we will catch fatal error. So if the predictor will fail to load the model, we will see an error saying failed to load Bitcoin price predictor model. And here we will display the error. So this line model try, it tries to find the compiled AI model inside the app and it loads it into memory. Now to make the actual prediction, we need a function predict next price. So it will take a double and we will make it optional because the prediction might fail. And here we need from current price. So we will try let model prediction. So here we will feed the data into AI and we will say previous price to current price. All this we will save in let prediction variable. Now let's return prediction predicted price. And let's put it inside the do section. Let's catch the error and print it. This must exactly match the input name the model was trained with. And if the prediction is successful, the model gives back an object containing the result. We access the result using its output name, predict the price, and return it. Now let's build the view model. So we go to our folder view models and we create an empty file and we call it BitcoinPredictionViewModel. The same as before, we are importing the foundation. And now let's call our class BitcoinPredictionViewModel. Let's make it observable object. And let's define our published variables. So we need actual price. And we need predicted price. And we need dates. Now let's create the prediction service as a private variable. So here we call our service that we just created. And in order to fetch and predict the price, we would like to create the function for this. In this function, we will define the URL string. The URL string is from CoinGecko. And we want to make sure that the URL is valid before we proceed. For this, we are creating the guard let URL. Now let's create a URL session. URL session creates a network task. This tells the iPhone, go to this URL, grab the data, and when you're done, run this block of code. So the block of code we need is guard let data equals data, let decoded equals try, JSON decoder, decode market chat response, self from data we return. And here I have an error because I forgot to put the empty space. Now we need to clean the data. We let all entries decoded phrases. Let entries, and we say date double equals to all entries map. So we say timestamp in let data equals to date time interval since 1970 timestamp array 0 divided by 1000, let price equal to timestamp array 1, and we return date and price. We use map here to loop through every entry. We convert the timestamp into a proper SwiftDate object. Then we pair it with the price. And now we need to group by day. For this we will use the calendar. So we need calendar equals to calendar current grouped by day equals to dictionary grouping entries, and we say entry date in components, calendar date components, and we say year, month, day, and from entry ID, actually entry 0. Now we return calendar date from components. We use this function dictionary grouping to group all our entries into buckets. So we have one bucket for each day. The API that we are using gives us multiple data points per day. Our model just needs one. So that's why we need to group in order to receive only the closing price. And now that everything's grouped, we will loop through each day and sort its prices by time and grab the last one. Sorted days equal to group by day, keys sorted. Now we have variable daily dates, date, and equals to empty square brackets, variable daily prices, it's a double, also equal to square brackets, and now we need a loop for a day in sorted days. If let day entries equal to grouped by day, now we let sorted day entries equal to grouped by day, day entries sorted Now we define if let last entry equal to sorted day entries dot last daily dates append day, daily prices append last entry dot one. Now let's generate predictions based on daily prices. We need variable predictions and we need another loop for I in 1 daily prices count if let predicted equals to self prediction service predict next price from daily prices I minus 1 predictions append predicted else predictions append 0. Now we want to drop first date to align with predictions. So for this we create adjusted dates array daily dates drop first, and also we create adjusted prices equals to array daily prices also drop first. Now we need a dispatch queue main async. We have here self actual price equals to adjusted prices predicted price equals to predictions and dates equals to adjusted dates. And now we need to resume. And that's it for this file. The next file we're gonna build is BitcoinPredictView and PricePredictionChartView. So let's go to our views folder and let's create a new empty file, and we will call it Bitcoin Prediction View, and the second file Price Prediction Chart View. Price Prediction Chart View is our UI view that we're gonna build in order to show everything what we've done before in this video. So we start with importing SwiftUI and charts, because we are going to visualize the prices in the chart. Now we defined the structure. Price prediction chart view. We define it as a view, and we let the variables, which are the actual, it is double, predicted, also double, and dates, which is a date, of course. Now we build our body. we need a vertical stack, and we say that the alignment is leading. We put some text here saying Bitcoin price versus prediction. And by the way, before building the whole page, we need the preview because we want to see the page being built in real time. So the preview will help us. For the preview, we need count, actual, we need predicted variable, so here we define just random variables, random values in order to display something. And when we run the application, then the data will be coming from the API. Now we need start date, current date, by adding day, value, count to date. And the last variable we need is date. Offset in by adding day, value is offset to start date. Now we return price prediction chart view. And we say actual equals to actual, predicted, predicted, and dates is dates. All right, so we have our preview. I don't think we can see anything right now, but let's try. Maybe only Bitcoin price versus prediction. Yeah, exactly. So we only see the text. Let's continue building the visualization. So after the text, we say our font. Let's make it title 3 bold. Okay, it changes to bold. And we also need padding dot horizontal. Now we build horizontal stack. We set alignment to top. We open parentheses and we build another vertical stack. And in this vertical stack, we want to add a chart. Now we need a loop from 0 dot dot 1 ID. We set to self, I in point mark. Here we set X and say value, it will be our day, and dates dot first date. Now we have Y. Here we also say value, but it's gonna be our price value, actual first and 0. And here we say opacity 0 in order to show the axis. You will see this axis in a minute. I think I have x double. We need only one x. So we see the numbers, but it's not a good chart yet. Now let's create chart y-axis. Axis marks, position to leading. Chart x-axis is hidden. Frame, width, and let's make it 50, and height 300. So now you can see the numbers better. Now we need scroll view, which will be horizontal because we want to scroll horizontally. And now we need another for each loop. Actual, indices, ID, self, I in point mark, open the parentheses, but it's supposed to be like this. And now we need again x and y is value for the day, dates, I. Y is also value, but for actual I. Let's add foreground style and make it blue, and another loop for predicted indices, ID, self, I in point mark, and now we have again x, which is value, day, dates, y, value, predicted. All right. Let's also add here foreground style, and let's make it orange. Okay, now it looks like we finished the file. We checked our parentheses. They should work right now. Yes, so they are working right now. And we can scroll horizontally. So each pair corresponds to one day. We can see the title, Bitcoin prices versus prediction, and this is our chart. Next, what we're gonna do, we create another view where we will insert this chart, but we will also add here the prediction price for tomorrow. So let's go to the file, and it's going to be a very short view, but we still need to import SwiftUI and create a structure, BitcoinPredictionView. Let's define this data object. It is a private variable called ViewModel. And here we will import BitcoinPredictionViewModel. Now let's create the body of the view. Here we need the vertical stack, and if ViewModel dot actual price dot is empty, we have a progress bar, progress view, loading predictions, else, and here we show the predicted price for tomorrow. If let tomorrow price equals to view model predicted price last, we display text Bitcoin price tomorrow, and here we have string format, and tomorrow price. Now we add some font, just headline, and padding, which is top. Let's also add the preview, and here we pass Bitcoin price view. Actually, price view is wrong because our file is called prediction view. Yeah, exactly. So now it's correct. After the padding, we want to add price prediction chart view. Here we type actual, which is view model actual price, predicted view model predicted price, and date view model date. Now let's add the button called refresh prediction, and we say view model fetch and predict padding, and then we say on appear view model fetch and predict. You imported the chart that we just built, so here you see the same chart, and on top of that we also have the predicted price for tomorrow. Alright, so that's it for today. In this video we created the linear regression model, we converted it to core ML in order to use it in our app, and we created the service, the view model, and two views in order to display the prediction.